Hi there, and welcome to the Data Science Salon webinar scheduled for today. My name is Jeremy Mason. I am the head of marketing operations for the Data Science Salon. And today we have a very special guest, Manasi Bartak, founder and CEO of Verda.ai, talking about model versioning. She's been presented at DSS Miami, and you may have also seen her at DSS Seattle. She'll also be at DSS LA. So she's here today to share with you some of her thoughts about best practices when it comes to model versioning. Manasi?
Hi there. Hi, everyone. Great to meet you all, and thanks so much for having me. All right, wonderful. Let's get started. So good morning / afternoon, depending on where you're at. Like Jeremy mentioned, my name is Manasi. I am the founder and CEO of Verda.ai. And today I'll be speaking about a topic that I've been working on for the last sort of 5 or 6 years, and it's very close to my heart. That specifically is model versioning, how to think about it, why you should be doing model versioning, and some best practices when you're implementing it. So let's dive in. A bit about me. So I finished my PhD at MIT a few years back, and my research was really around data science and ML systems. So what should the next generation of data science and ML systems look like? Who are the people who will be interacting with them? And what are the new paradigms we should be thinking about to enable ML and AI to be used across the enterprise? I also was very fortunate to work on the ML teams at Twitter, Google, and Facebook. So I've seen both sides of the coin, so to speak. What does it take to build models? And also, what is the infrastructure to support the building of these models? I built a system called ModelDB while I was at MIT. It's open source. Please feel free to check it out. And the goal of ModelDB is to help teams manage all of the models that they are building. Verda.ai, my current company, evolved from that work. And I'll give you a little taste of what Verda does towards the end. We build platforms to enable data science teams to productionize their models rapidly and with confidence. A bit about Verda, since we are relatively new. We are a company in Palo Alto. We built infrastructure, as I mentioned, and we're a group of folks who are super excited about bringing the power of ML to every company out there. All right, let's dive into model versioning and how you go about doing it. So most people on this webinar probably have built models or supervise a team that builds models for a variety of applications. Maybe it's propensity modeling, maybe it's image recognition, and so on. And what we've seen time and time again is that most ML projects don't make it to production. So either the models aren't good enough, or getting them into production involves getting a lot of data sets in place, making data available in real time, and so on. But the sum total is that most projects don't make it to production. It also takes between 9 to 12 months to bring an AI project either into a customer's hands or to implement it into a business process. I was recently speaking at a conference where a quick view of all the talks gave a sense of what are the key questions that are on people's minds. So some of the titles I'm sharing here, they were, how do you overcome challenges in bringing models to production? Now that you've trained a model, what do you do next? Or you have a model as a service now. What does that mean for your production systems? How can you make sure that your models are behaving as expected? And finally, operationalizing this whole thing that is machine learning and AI. So in my research at MIT and previously, we've been looking at what are the challenges for productionizing AI and ML, and what are the tools that a team can build or buy in order to help them in this process. So let's take a look at what these are, and I'll link that to how model versioning can help you solve these challenges in productionizing AI and ML. So first off, if you're a data scientist, you'll probably know that everyone builds models in a unique fashion. There aren't a lot of best practices around how do I manage my machine learning experiments. And every so often you'll find an interesting thread on Reddit or Twitter where people are discussing best practices. Since there's no good way to track model development, it turns out that it's hard to also share data science knowledge. This happens when, say, a new person joins a team or someone from your team moves on. In that case, how can you pick up where they left off and continue to build great models? Once you have models, we found that getting models from training to deployment is also challenging. The process is slow and brittle. Finally, for models that are deployed, we want to make sure that they are working as expected. This means that there is no model drift happening, there are no outliers, your missing values are also under control. So if you think about this whole spectrum, everything starts with building a model. And so the key part that we want to address here is ad hoc model development. And by the end of the webinar, I hope to convince you that if we do the first piece of these 4 challenges, if we address the first of these 4 challenges correctly, then we can reap the benefits of it, both for sharing data science knowledge, for deploying models faster, and also monitoring them on the go. So that's why the topic of my webinar today is model versioning. All right. So why must I version my models, right? Like I build models all the time. What is so important about versioning them in a particular manner? So let's look at some data points. So this comes from my PhD thesis. We looked at all the Kaggle competitions out there. I'm showing 10 of them here, and we looked at the number of submissions made by the top 10 ranking teams for these competitions. You'll see one thing off the bat. Most people build hundreds of models before they win a competition. And mind you, this is only the best models that they submitted. This is not the whole host of models. So you can easily multiply these numbers by 10 to get an idea of the total amounts of experiments that went into building a model. Now, we're building these models. However, the state of the art for keeping track of these models is as follows. Either you have a folder structure, and this is actually mine, so I've been there, done that, where we give very peculiar names to all of the files and folders, and finding them again is a massive headache. Sometimes we've also seen data scientists comment their code in order to keep track of the versions of experiments that they're running. This is from a real Kaggle kernel, where you can see all of the versions that this person has tried. Now, if a software engineer had to do this in their regular job, I think they would actually quit. But as data scientists, we don't have a good way of keeping track of our code. Finally, think about how you share your models with others on the team. I asked a friend of mine who works on medical AI, and here's what she replied with. Here's some messages from their Slack channel, and they say, does anyone know if so-and-so ever updated her notebook to fix this dependency issue? Other than that, we're pretty close to deploying, right? Now that's pretty scary. These are the models that are going to be powering either our medical application or self-driving cars. If we don't even know where they're coming from or what version they are running, I'm not sure I want to be treated by that sort of AI doctor or sit in the self-driving car. So we've talked about model development and how important it is to get versioning right during development. However, getting a model running on your laptop isn't the end of the story. A model only has an impact if you deploy it. Once it's deployed, you make sure it's running as expected and you get all of the great data coming out of the model to improve your next iteration. So let's look at why versioning is important in these other steps of the life cycle too. When you deploy a model, you want to know what version of the model is deployed. If you need to roll back a particular model, you do need to know what the last safe state of your model was. When you're monitoring a model, you want to know if there is data drift. You want to know what the expected values or distributions of predictions are once a model has been deployed. So the key point here is model versioning doesn't just start and end with development. It starts with development, but is essential throughout the entire life cycle of the model. So to summarize, why should you be versioning your models? First of all, safety. You want to know what model is deployed, how it's functioning at all times. It lets you improve your speed of delivery. If you have a versioning system, you can use existing best-in-class software tools to deliver your models to consumers of those models downstream. Next, it's insurance. If someone leaves your team, you want a way to preserve the knowledge about all of these models. And finally, it's about productivity. If we don't have a good sense of the previous experiments that we have run, it's harder to know where you're going next. So that's a quick view of why version. I'm happy to take more questions about that in the question answer section of the webinar. Let's keep moving. Now that we know why we should version models, let's look at how do you do that. A quick segue into code versioning to really draw a parallel to what we're talking about. The first code versioning systems were written for Unix, and this was in the 1970s. And since then, we've had 5 different generations of code versioning systems, whether Subversion, CVS, Git, Mercurial, whatever system that you're most familiar with. And this really makes you think, if our code versioning systems are so robust, do we need a different model versioning system? And in the next few slides, I will convince you why models are actually a different kind of beast. The kinds of things you need to account for models are quite different from those when you're talking about code. So the crux of the issue here is, what is a model anyway? Is it a function? Is it a set of assumptions about the world? Is it an object in Python? Or is it a set of neural networks? This is a topic that we used to discuss to no end when we were building ModelDB. And what we realized that everyone uses the word model differently, and we chose to impose the following definition to make sure we had a common vocabulary to use when we were building models. So in ModelDB, and a definition that we're using with customers of Verda, for us, a model is an artifact. So this is a binary. This is a serialized version of a pickle file. It could be a POJO object. It could be a PMML file, whatever way that you represent models. And the key thing is, just versioning this artifact is insufficient in a way that versioning, say, a mobile app, just the app that runs on your phone, is not sufficient. You also need to version everything that created the model. In this case, it means that we're talking about code, the actual Python code, R code that you might have used in order to build the model. It includes the data itself. So whether it was a CSV, it was a query that was run against an RDBMS, maybe it was a Kafka stream, whatever is most appropriate. Then the configuration. So how did this model come to be? Was it a logistic regression model with C equals 10, LBFGS solver? What were the parameters there? And finally, the environment. If you work in Python, you will have seen the necessity of having very accurate dependency management. Different versions of libraries can give you very different results. And so capturing the environment turns out to be crucial in a model version. So in our view of the world, when you're versioning a model, what you're really versioning are these 4 things: code, data, configuration, and environment. So if you think about the parallel with Git, could we be using Git to version our models? Well, the model artifact doesn't really live in Git because Git is not meant for large files. Your source code could live in Git. Your data most definitely does not live in Git. It lives in an S3 bucket, or it could be living in an RDBMS. Similarly, your configuration could be in a file. However, it makes it that much harder to query that configuration or build charts with that configuration downstream. And so we think that configuration actually needs to live in a metadata or a model database. And finally, environment could be a file, could be in a source version control. So the sum total is that when you're versioning models, you need to make sure that you have a place to version your artifacts, to version your code, your data, and your config and environment. All right, so that's a quick view into how you would version your models. Let's look at what a versioning system architecture might look like. So we're saying here that there are 3 different data scientists who are building models. Similar to Git, we envision a central model versioning server. You can pull and push your models using the schema that we defined earlier. Now we've gone through why and how one must version models. Let's go over quickly when should a data scientist version their models, and then I'll show a reference architecture for what a versioning system looks like. So when should you version your models, right? Can you do it after you've built your model and you just have your pickle file? Is that sufficient? I would argue that no, it's insufficient. And the reason is as follows. When you're versioning a model, when you're developing it, you're versioning your code, your data, config, and environment. When you deploy a model, what you need actually is the model itself, which is the artifact, the dependencies, which come from the environment, and something we call the model API. I won't really talk about this right now. Happy to talk about it offline or in the questions. So when you go off to deploy a model, you already have the data you need for deploying it if you version the model correctly. We already got 2 out of the 3 we need for deployment. Then let's go to monitoring. This is making sure that there are no anomalies in the data your model is seeing. There's no data drift going on. In this case, again, what you need is the model, the endpoint, and the model API. We already have the model since we did model versioning, and we have the model API too if we've configured the system that way. Again, 2 out of 3, we're looking good. Finally, when you come to the retrain step, so this happens when there are new annotations or you have new data on which you want to train and update your model. In that case, the information you need is exactly the information that you started with when you were training the model. As a result, we find that versioning your models early on helps you take the models all the way from development, deployment, through monitoring. Awesome. All right. So let me give you a quick view of what a reference implementation might look like of a versioning system and how that integrates with a broader ML platform. So this is the Verda platform that we have built and offer. And I want to highlight how model versioning fits into it. Usually you train models in, say, a hosted system. You're spinning up a Jupyter notebook. Right when you start building the model, we recommend that users start versioning it. So that goes off and lives in a database. It becomes a central place from where everyone can find previous models that have been built. Perhaps you have features that you want to share as well, and they can all go and live in a centralized versioning system. That's number 2 in this diagram. For number 3, once you have a central place that tracks all of the models, similar to GitHub or GitLab, with one click, you can go off and deploy your models. Now, this could be using Jenkins. In our system, it's just a one-click deployment. I have a model that's been versioned using a particular schema, so I can deploy it very easily. Once you've deployed the model, again, you can monitor it and retrain it. The key part, as you'll notice, is all of these arrows ultimately come back to the versioning component in the middle, because that is our single source of truth for all of the models across the enterprise. So if I want to know what are the marketing models that have been built, I can go to central place and look at all of the versions of the models that the marketing department has produced. If I want to know what is the version of a model that's running in our application, there's a central place that I can return to and find out all the information necessary there. All right, so that is one reference implementation. Depending on how your system is set up, there might be a variation of this, and happy to take more questions during the Q&A session coming up in just a few minutes. Okay, so for the next few minutes, let me close out by telling you how model versioning can enable your data science team to move fast and bring more models into production. So here I'm going to present a case study. This is a sales AI company called LeadCrunch that we work with. They are one of the top companies in California. They have a 5-person data science team, a separate engineering team, and they build very innovative models that are taking website data, understanding customers, and also recommending to users what are other customers that they should be targeting. The challenges for LeadCrunch were as follows. Their model development and deployment was slow. They also had a lack of ability to innovate on models because of their particular setup, and it was hard to track and share work across the team. So I'm going to give you a quick view of what we did there with an emphasis on model versioning. There are also other deployment capabilities that we implemented, but that's not the focus of this particular presentation. So what we did for LeadCrunch was as follows. The first thing we do whenever we work with a team is we help them set up a central model repository. So we go in, we are installing a library in Python that will version all of the models as they are building them. We will also version the datasets and set up the versioning server so that their work can be shared across the whole team and the entire company as well. Once you have a model repository, a central versioning system, everything downstream becomes easy. It enables you to do self-serve deployment, auto-scaling workflows, and monitoring. We implemented these changes in less than a week for this particular customer, and after that, we ran a 3-month-long longitudinal study to see what impact these changes would have on their data science team. Here's what we found. First thing off the bat, having a central model repository enabled them to get visibility into all of the models that they were building. This included, traditional scikit-learn models. This included massive ensembles that they were sharing and building. It also included BERT models and really cutting-edge XLNet and NLP models. Suddenly, as a data science manager, their manager could see all of the models that his intern was building, all the models that the analyst was building, and the models that this very advanced data scientist was also building. It helped them see what fraction of their models were coming from Python 2. It also enabled them to use any ML framework of their choice and be able to deploy it in a way that the data science team was not bottlenecked on the broader engineering team. Their time to develop and test a model went from 22 weeks to 3 weeks. That's about an 8x decrease. The time to deploy a model actually reduced from more than 3-month delay to just under a day. And this had to do crucially with how the model was versioned and packaged. Finally, from a business perspective, the number of model deployments a year went from 2 model deployments a year to over 1 deployment a month. That's a massive increase that is already showing them returns on their business KPIs. So this is just one example of what model versioning can enable, not only for sharing knowledge within the data science team, but also to enable better and agile working of the data science team downstream. So quick summary, we found that the right tools are key: model management and model deployment. If you can put in the right practices to enable this to come in. And we found that we can ship more than 8x models. We can ship more models faster, we can have more product impact, and enable more applications. Great. So to summarize, I've given you a quick view of what the challenges are in productionizing AI and ML, and how solving this first challenge, which is ad hoc model development, can help you streamline your processes downstream, including deployment, sharing of knowledge, as well as monitoring. So if you are a data scientist yourself or data science team leader, I would encourage you to think about how model versioning can be integrated into your day-to-day workflow. I hope I also gave a sense of how model versioning is not just like code versioning. It requires source control, data config and environment management. And the case study, I hope, gave a sense of how collaboration, deployment, and monitoring can be improved with model versioning. So that's all I have. We at Verda are building a platform that enables the complete model lifecycle, and we would be glad to help any team out there who is trying to become agile with their data science and ML. I'd be glad to send this particular case study in our follow-up email, and we always do trials for teams who want to figure out what is the right ML platform for them and how Verda can help. So that's my contact info, and also a link if you want to sign up for a newsletter. Please expect to hear from me in the email that follows, and I would be glad to take questions.
Okay, I have the first question from the audience. How do you version data?
Absolutely. This is a great question because your models are quite different from data. At the same time, if your data changes, then your model also changes. So a key part of our tooling is a way to version data. And depending on where your data lives, the data versioning story is going to be different. So if your data is in the form of CSVs and they're uploaded to S3, then in our system, we have chosen to version the objects on S3. So if you update a particular CSV or you add a new CSV to your S3 bucket, our particular system can automatically detect this change and associate the new data version with your model version. If you're in an RDBMS setting, so like a database, then we will track the queries and metadata that was associated with the results of your query and tie them together with the model versioning. So depending on where your data is coming from, there are different ways to version your data, and happy to talk about it more offline as well.
Any other questions before we wrap up? All right, we have another one that just dropped in. How does versioning help deploy?
Got it, got it. So I mentioned this briefly earlier. When you're thinking about how to deploy models, the things that you need are as follows. Most teams out there will deploy a model by packaging it as a Docker container and then running it on a system like Kubernetes. That's what we do most often, and we help others do as well. When you're building this container, there are usually 3 or 4 things you want to get right. The first one is, what is the model itself that you're going to be deploying, whether it's a pickle file or something else that has the serialized version of the model. The second one is, as I mentioned before, requirements. And we have been bitten by this time and time again, where Python has very specific requirements around libraries. And so you want to get those library versions just right. And something I mentioned earlier, we found to be very useful is the model API. So this is telling a consumer of a model downstream what the inputs and outputs of the model should be. So what is the contract for this particular model? And in our view, when you're building a model, these are all the 3 things that you should be capturing in your model version, because you know the serialized version of your model when you build it, you know the environment, and you know what contract your model is supposed to be exposing. So doing the versioning right and collecting this information at that time can help your deployment be extremely streamlined as well.
All right, well, that takes us to the end of our time for this webinar. If you have any other questions that you thought about but didn't get a chance to ask, we will be sending a follow-up email for this webinar, so feel free to respond to it and we'll definitely get your answer to you. Thank you so much, Manasi, for your time.
Thanks so much for having me. This was great. And please feel free to reach out. My contact info is right on that slide.
Okay, this concludes another edition of the Data Science Salon webinars. We'll see you at the next one. Bye for now.
Bye.